something, there's all kind, well, I don't say there's all kinds of surprises in this chapter, but we do some different things in this chapter. One of those things starts with the word proof and ends with the word party. We will end up doing a proof party. So that's something you can look forward to. And some other things too. And one of those is that, remember how maybe back in elementary school or junior high, you put the problems like up on the chalkboard, or maybe not. Nobody ever did that. You know, you might come in and put your homework up on the board. Well, I end up using a strategy like that. It's kind of intentional, and it's not just to sort of waste time because we don't have any time to waste, but end up doing a strategy where you guys are going to be, I'll say required. It's actually a small grade. It's supposed to be an easy grade, but you'll be asked to put up, I'll use the word asked to put up 4 problems throughout the chapter. Okay, now the problems that you'll put up might mix and match between homework problems. Sometimes there'll be something we practice in class, and you'll kind of get the idea pretty quickly that I'll have the blackboard partitioned, like just basically I'll draw lines through it, and there'll be like a 1, 2, 3, and that's your sign to put up that problem. Okay, now it's kind of first come, first serve as we go through sort of each cycle. So if you put up a problem, you're like on Monday, you're like, I want to put up number 1. That's fine. You can put up number 1. Like I said, kind of first come, first serve, but then you have to give everybody a chance, and I'll let you know, but you give everybody a chance to put up their first problem. Okay, so maybe you kind of like wait a couple days until you put up your next one, and then your next one. Now, listen, there's many, many opportunities. I think I counted, there's 54 opportunities to put up problems, and I'm asking you to put up 4. It's a simple math problem. There's plenty to go around. Okay, now it does require you to kind of be active and to be like doing the problems and say, hey, yeah, I want to put that one up. So yeah, that's kind of the idea. And the other idea is that because of the nature of this chapter, your classmates want to see the problems. And so this is just a way for everyone to sort of be able to share the information and see the problems. Okay, because honestly, I won't be able to put all the problems up. You don't want to watch me do that. And it's just it's better to have you guys get involved with that. Okay, it'll last like 3 or so weeks. You'll catch on real quick. Monday, the blackboard will kind of be partitioned. Yes, the answer is yes. That means put that problem up. Okay, and like I said, first come, first serve, but then you wait until I sort of give the okay that, okay, everybody's had a chance now. You can put up another one. Sometimes you'll put 2 problems up in a day. That's because people will kind of be sitting here and they won't maybe be ready to put up another problem. And you're allowed to do it, okay, once I kind of give you the okay. All right? It's a small little grade, but it's actually more helpful than just the grade. It's helpful, as I said, for people to be able to see the math, okay? All right, well, we're going to make My First Identity Book. Yes, you're going to make a little book today. It's called My First Identity Book. You can like put it on your nightstand. Before you go to bed, you'll want to read it kind of as a bedtime story. And inside it, as you can see, are the identities. Okay, you're going to put the identities in here. Now, if you're kind of like too cool for school, you might be like, do I have to do this? The answer is yes. And if you're like, that sounds cool, yeah, you'll use this. Like kids will pull this out next year. They'll pull it out of their pocketbook or their wallet or their book bag. It's actually something that you guys will look at often. Okay, and it's kind of fun. It'll give you a chance just to kind of get used to the identities. I'm actually going to give you a little class time to do it. That's what the piece of paper is for. Okay, are you happy with like the color you picked? Are you going to be able to write on there? The color you picked probably says something about you. I don't know what it says, but it probably said something. But here's what you need to do. I guess I need to help you make the book. Have you guys ever made one of these before? Got to get the paper folded a few ways. So we want to fold it this way. That's like, I guess, a hot dog, since we were talking about hot dogs. So you fold it like a hot dog. And then you want to fold it the other way twice. Okay, you want to fold it the other way twice. You're trying to get this thing down to like a little, what are we looking at here? Like 8ths, I think, but fold it long ways and then fold it the other way twice. I've seen people really jazz these up too. If you are that kind of person, somebody once was able to do this with multiple colors. Maybe that's something you work on at home if you really want to. Now, once you get that thing folded, you actually want to open it back up because it's not ready to behave like a book yet. So just open it back up. And then you fold again in a way that you already folded, but sort of across the grain, you'll fold down like this. Again, the folds are already there. I think one of them you should feel like you're folding across the grain. So fold it down. And then you should, at this time, have like a creased side. You'll have a creased side. That should be at the top. Okay, now here's the important part. You don't need to draw on yours, but I'm going to, just so you can really see it. You have to do a little tear. Maybe scissors if you need to, but you do a little tear from the top, from the crease, halfway down. Okay, so you're going to tear from the crease side halfway down. Yeah, only halfway. Just this blue line. You can tear it if you make that crease, or you can use scissors. Make sure you tear halfway down. If you tear the whole way down, you just kind of like tore your book. Now, they call this thing a poof book because what we need to do now is kind of make it go poof. Okay? Yes, it's a proof book, or maybe you think it's a proof book, but I guess the maker of this, it was really a poof book. What you're going to do is you're going to put your hands or your fingers kind of like underneath here, and sort of with your thumbs, you push up and you make this thing go poof. So it takes a little skill. Get your fingers and your thumbs kind of in a way that you can push in, and at the same time, it sort of goes poof. It kind of becomes three-dimensional, almost like a cubicle. If you're having trouble making it go poof, I will come to the rescue unless you really want to do it. That's right. And then you just turn that into a book. Yep.
It's not going poof.
It did, actually.
It did?
Oh. And then you can clean up, and there's your binding.
I just
All right, now I'll show you the sort of the plan for the book, how you can kind of lay it out. And I'm going to give you a little time to do this. We actually do have some learning to do today too, but this is part of it. I'm going to recommend kind of the following outline. So the front cover, call it what you want. I kind of like the My First Identity book. It's kind of cute. But you got the front cover. And then when you open up to the first page, the second page, I'm suggesting that you copy in the reciprocal and quotient identities. Now you'll probably have to open up your notes and maybe just remind yourself of the things we wrote down yesterday, which is fine. So on the next page is the reciprocals and the quotients. The center fold, the center page, we reserve that for the Pythagoreans. And then as you get towards the back of the book, there'll be some stuff we're actually going to fill in. The illegal, legal, again, we will actually fill some of that in a few minutes. As we go through the chapter. So we have these double angle identities. I didn't really derive them or sort of prove them to you. I just kind of, boom, here they are. I gave them to you. But it's interesting, if you take a look, what they are saying is that if you do the sine or cosine of twice the angle, so that's why it's a double angle, because we're doing twice the angle. For sine, that would be the same as twice sine times cosine. And then for cosine, that would be, this is interesting, cosine squared minus sine squared. We don't actually talk about where those came from. So if you're kind of like, well, why is that true? Yeah, I'm just admitting I didn't really explain that to you, but we'll use them a little bit as we go through the chapter. Okay, now the other part of this chapter is really just kind of understanding what is illegal and what's legal. I mean, to be honest, the whole chapter is kind of about figuring this out. This is just a little bit of sort of scratch the surface and give you an idea of, okay, you can't do this, but you can do this. And what I'm trying to do is I'm trying to pick out some of the common mistakes. So when we say illegal, we're talking about taking something that we understand, like sine squared plus cosine squared. So just to be clear, that is definitely true. That is a legal idea. But the problem is when students do something illegal to it. Okay, and here's maybe like the number one mistake is where people are like, well, you got these squares here, so then I should be able to kind of like square root them away, right? Wrong. Actually, that square root that I'm implying is not legal algebra. And so it definitely is not true that sine plus cosine equals 1. I mean, it just kind of doesn't look right. Okay, because it has to be sine squared plus cosine squared. So it's illegal to say that sine plus cosine could equal 1. So we want to stay away from that. What's another sort of common mistake? It's hard to put down every mistake, but I am trying to pick out some of the common ones. Once again, you start with something that makes perfect sense, but you basically do something illegal to it and come up with a false statement. And so here's a common one for people to say that maybe if I put like a subtraction sign in here, if it's sine squared minus cosine squared, well, that should equal -1, right? No. Okay, so maybe the moral of the story is we don't have an identity for sine squared minus cosine squared. Okay, interesting. We do have an identity for cosine squared minus sine squared. That's kind of a whole different set of properties. This is not true. I can't just throw a minus sign in here and suddenly equals -1. But what we could do, let's go over to the legal side of the book. What we could do, I'm going to write this down again, because as long as you start with something true, and as long as you do good algebra, like multiplying this side of the equation by -1, kind of easy stuff, right? And multiply this side by -1. I mean, that's good algebra. It's also pretty simple, but look what you get. You get negative sine squared minus cosine squared. Well, that would equal -1. Okay, that is definitely true. And again, that's a real simple look at how to do something legal, but that's how you get a negative sign involved. Let's do one more, which we actually did yesterday, but I'd like you to have it kind of in your little book. So I hope you would agree with me that tangent equals sine over cosine. That's definitely a quotient identity. Now, if I do something legal to both sides, like square both sides, and of course, remember how to square a fraction. Okay, simply you square the numerator and denominator. And that's why we end up with this statement that says tangent squared is going to equal sine squared over cosine squared. A statement we actually used near the beginning of yesterday's lesson, but this is a little bit of kind of why it's true. As I said, a lot of this chapter is going to be figuring out what's legal and illegal. Okay, this just gives you a little bit of an idea. Be careful with your algebra is kind of the moral. Anything else with the book? Okay, you can jazz it up, decorate it, laminate it, whatever you want to do, but nice resource to have handy, again, as we go through the chapter. Now, what I would like to do today is kind of start getting to the business of using the identities. So we're going to use the identities to do all kinds of stuff. First thing we're going to do is we're going to find trig values. Okay, now there might be a point in the next 10 minutes where you're like, didn't we already do this? Yeah, we already did this. We just did it using a different method. We basically used a triangle method. What we're going to do right now is we're going to use an identity method. And just hear me out. There's not many times this year where I say, you must do it this way. But this is one of those times where I want you to use an identity. Okay? Most of the time this year, it's like, hey, if you can get the answer, use any method that works. But I'm sort of trying to force you to use something new just so you get comfortable with the identities. Okay? But yes, I'll say it again. We did do this another way near the beginning of the year. But right now we want to use the identities. So we're going to use the identities, and we're going to do that to find trig values. Let's see what this is all about. This is kind of also sort of a quick lesson. That's why even though we have a little less than 15 minutes, we should be good. But it gets us kind of warmed up into thinking about the identities. All right, kind of have to write out the problem because you have to see the language. So it says if sine of theta equals 5/7, find the cosine of theta. Just make sure you understand that we are not trying to find theta. Sometimes people kind of know too much. So we're trying to find the cosine of theta, which is quite simply a little bit of sort of a theory question. Okay, now to do this, what we want to do is we want to use an identity. And I see some of you looking in your identity book, which is good. But let me kind of give you a little strategy. You want to use an identity that uses only sine and cosine, because it's kind of like we want to use what we're given and we want to have what we're trying to find. So we kind of look through the book, and you should get past the first page, okay, because those identities don't use just sine and cosine. You should go past the second page, which is the quotients, because those seem to use 3 identities. And you open up to that wonderful center page, the Pythagoreans. Okay, the Pythagorean identities, in fact, the main one is going to be the one that we want to use. We want to use sine squared plus cosine squared equaling 1. Why? Well, because that's the identity that uses sine and cosine. Now you say, but Miss Naylor, it uses sine squared. Right. Okay, so what happens here is when I plug in 5/7. Now be careful. I'm not plugging in 5/7 for theta. Okay, I don't know what theta is, and to be quite honest, it doesn't matter. But I do know that sine equals 5/7. So it looks a little bit more like this when you plug it in. You literally plug in 5/7 for sine. And I get 5/7 squared. So again, I plug 5/7 in for sine, and I get 5/7 squared. Now, I told you this is like the algebra chapter, so you kind of should feel like, doing a little algebra. Namely, you should feel like you're going to solve this equation for cosine. We're going to solve it for cosine since that's what we're trying to find. Okay, now, as you do that, think about some things that are true, like squaring this fraction is going to be, well, the squaring of the numerator and denominator. So we get 25 over 49. Some other things that you sort of should be thinking about here is how to isolate cosine. Not real hard algebra, but we want to do it carefully. You want to subtract this fraction. I will sort of caution you against using your calculator a little too much right now. To be honest, I think that you guys need to be able and should be able to take 1 minus 25/49ths. Okay, I'm not trying to like scold someone if they want to use their calculator, but you should be able to make a common denominator here. And real simple, the number 1, if it's going to look common, is going to need to be rewritten as 49/49. Okay, so now I have a common denominator and I can subtract the numerators. So we're subtracting 49 minus 25 to get 24/49. Okay, there's only one step to go. It's to take the square root of both sides. And as we do that, we want to be sensitive to how to square root that fraction. Basically, is there anything that needs simplified? You know, like the square root of 24. You should feel like that inside the square root of 24 is a 4 that you could pull out as a 2. It leaves a 6 behind. So we simplify the square root of 24 to be 2 root 6. And of course, the square root of 49 works out nicely just to be 7. Take a look at that answer. Okay, that's the kind of answer we want to see. Like, in other words, we don't want the decimal. Trig values. Okay, now if you're like, we did do this before, remember 5/7 would refer to the y value on the unit circle. This guy right here would refer to the x value on the unit circle. So officially, these two fractions represent a point on the unit circle. It goes back to those first 3 weeks of school. Just a little different way to find that answer. Let's do another one. Maybe you'll kind of be able to do it on your own. Maybe I'll need to provide a little input. Usually after you see 2 of these, you start to get the idea of how to use the identities to find a trig value. Now I'm changing the letters around just because I want you guys to get completely comfortable that it really doesn't matter what variable is written. Doesn't matter if it's theta, if it's x, or a. Now, do you guys remember the strategy? You want to find an identity that uses just these 2 trig functions. So you're looking for an identity that uses tangent and cosine. And I should emphasize only tangent and cosine. Only. How's that going? Anybody find tangent and cosine? Oh man, we even wrote the book. Where is it? Okay, well, it's a little covert. You sort of have to read between the lines. You have to read between the lines. Isn't cosine sort of the brother of, sort of the reciprocal of another trig function? In other words, if we find secant, haven't we in a sense found enough information to get cosine? Follow the sort of the strategy here. We're going to find secant because it's basically one step away from cosine. Okay? Because again, they're reciprocals. Now, do you guys see a tangent secant identity? You should. You should be able to find a tangent secant identity. It goes by tangent squared plus 1 equaling secant squared. You want to see if you can plug in 2/5. You want to see if you can work this out. And then keep in mind how you're going to have to do an extra step at the end. Okay, so you make a common denominator, pretty common because the number 1 seems to show up a lot. So we need a common denominator of 25. The number 1 is equivalent to 25 over 25, so it works out nicely to be 29 over 25. Now remember, that's secant squared. So you do have to take the square root, and when you take the square root of both sides, you get secant, which is root 29 over 5. Okay, that's secant. Now, as you guys, I hope, will begin to get comfortable with, basically, if somebody tells you something about secant, then in essence, they're also telling you something about cosine. Because all I have to do is the reciprocal, and I can say that cosine, and I do mean this, you can just kind of do the reciprocal. You don't need to show like 10 steps. You just do the reciprocal of root 29 over 5, and now you have a cosine statement. Now remember, that's what we were trying to solve for. We were trying to solve for cosine. Pretty good. Just one little problem. Another book. It's the math etiquette book. Okay, maybe we should make the math etiquette book, because if you turn to page root something, if you turn to the root page, it says no roots in the denominator, right? You can't have that square root down there. So you can show that if you want, or you can just do it, because you have to rationalize the denominator. I know that answer maybe looks more complicated, but technically it's more proper to say 5 root 29 over 29. Now, the other good news is that the rest of this chapter is a whole lot more exciting. Okay, this is not what the whole chapter look like. There'll be a lot of neat things we do. I can't wait to show you guys some of that on Monday. Just kind of kids get interested in it, but it's kind of a start. It's the first thing that we do, a little trig value. Lastly, if you're saying, do I always use a Pythagorean identity? Not necessarily, okay? You notice the 2 problems I did use Pythagoreans, but you might end up using other identities. So when you look at the homework helper, pick an identity that uses the 2 trig functions.